Okay, can you see the screen?
Yes, sir.
So the article 6.22, this is very important, how to generate the firing pulse or triggering pulse of the thyristor. So in the last class, we have discussed this one. If you remember that, we call it phase control rectifier. So suppose this is your VS. So VS will have that sinusoidal voltage, VS equal to say √2 VS sine of omega t. So if so, then what will be this one? Can anyone tell me? What is this value from this equation?
√2 Vs.
√2 Vs. √2 Vs is nothing but the Vm, the peak value of your sinusoidal voltage. So this one is pi, and this is twice pi, and this is your omega t. Now when we want to fire this, suppose we have applied this to sinusoidal. So for the negative cycle, if you apply any firing pulse, will this thyristor T will conduct or not? That is the main thing. I want to know from, if you go back to your characteristics of your thyristor, suppose this is your IEA, and this is your say VAK, anode to cathode voltage. This is your VAK. Then I told you, you will get, if I apply a gate pulse, then the thyristor will start conduct. So look here, this VAK, A to K means the anode to cathode. This is your anode, and this is your cathode. This anode to cathode has to be positive. So from this sinusoidal, which half cycle is positive? First half cycle or second half cycle?
0 to pi.
0 to pi is the 0 to pi is the span of time where your thyristor is forward bias. That means we must, to operate the thyristor, we must maintain the forward bias of the thyristors, right? And then not only that, we have already shown you in the previous class, if you don't apply any gate pulse, then the current will be 0. Right? So if suppose we did not, this is your gate pulse, IG, we have not applied any gate pulse here. So what should be the output voltage? We did not apply any gate pulse. What should be the output voltage? Sumaitha, tell me, what is the output voltage? I have not applied any gate pulse. Look here, this is the gate pulse. I have not applied any gate pulse from 0 to twice pi. This is your twice pi, this is your pi. So what should be the output voltage? Can anyone tell me?
0.
0. Why 0?
Sir, you haven't applied any gate pulse, so it will not give any output.
Yes. I have not applied gate pulse. That means what
will
will
not
be
conduct.
Conduct.
what will be the biasing condition of this?
Reverse.
Sorry, not biasing condition. What will be the switching position of this thyristor?
Switch
Turned off.
turned off.
Turned off, right? If it is turned off, then your current will be say IA will be 0. Then your the voltage output voltage say here sometimes people call 3D. 3D equal to IB or IA, whatever IA we have right here. If it is 0, so output voltage will be 0. Then you see that output voltage will be 0, right? I am reviewing. This is still reviewing. I have already discussed all this in the last class. Now, so this is the phase control rectifier. It means that phase is that 0 to pi. This is the phase angle, right? 0, 0. Then this is your pi by 2. then your pi, this is your say 3 pi by 2, and this is your twice pi, right? So this is the phase. Do you know what is the phase of any AC alternating current? Or how do you define the phase? I'm not talking about the phase difference rather than phase. Meaning, so who taught you the AC alternating current? Teacher, I'm asking you, the teacher who has taught you alternating current. AC alternating currents. Who taught this one? You forgot the name of your teacher? Hello.
Yes, sir.
Can you? Who taught you? Who taught?
Honorable sir.
Ruel sir. Okay, then.
So phase is the angle. Phase is the angle of the sine or cosine.
Yes, that means
This is
look here. This is your phase position omega t. Depending on
the
the t.
argument of the sine or cosine.
Yes. So when omega t equal to 0, you look here. Vs will be 0. When omega t will be the pi by 2, it will have the peak value. When it is again pi, it is 0. So this is the phase. Phase means the condition of your sinusoidal. So this is the phase control, means that we will apply the gate pulse in from 0 to twice pi. Now, if I apply the gate pulse here, say gate pulse here, we have already discussed this in the last class. Suppose this is your alpha. If alpha equal to say 30, for example, then suppose this is your alpha. So 0 to alpha, then what will be the switching condition of this thyristor?
Sir, the thyristor will be off.
Oh, okay.
Zero
So
volt.
there will be no volt, there will be no current, so we will not get any voltage. So voltage will be 0. And then when this firing pulse has been applied here, say here, at omega t equal to alpha, then the thyristor will start conducting, it will be shorted. So your V0 will be equal to your Vs, right? So our Vs is this one. So Vs is this. And also if I plot the current will have that wave shape like this. So current is 0 here, and also the voltage is going negative. So from pi to twice pi, what should be the switching condition of this thyristor? Pi to twice pi. Negative cycle. I have not. Yes, I may apply any pulses here. But what will be the switching condition between pi to twice pi?
Turned off.
Off.
Because why? The thyristor is reverse bias, right?
Yes, sir.
So what is the condition? What is the necessary condition to turn off any thyristor? It must be reverse bias and current through it must be equal to 0. So is the current 0 here? This is the
So from pi to twice pi.
no, at omega
Is
t equal
0.
to pi, 0. So current is 0 at omega t equal to pi, and also you look after that the voltage is negative. So the thyristor will stop conducting from pi to twice pi, and even for the next half cycle, if you apply the pulse again at omega t equal to twice pi plus alpha, then only it will be conducting, and then the output voltage will be like this. It will be only for the we have already discussed these things in the last class. Did I not? Yes or not?
Yes, sir.
I told you this is my suggestion for every subject. Please just you go through the previous class before coming to the next class. If you do that, I am giving you the guarantee that you don't need to even read anything. Take much preparation for your exam. So this will be your output voltage. So the problem is that like how we will generate this gate pulse, and we must have to monitor, or we must have the knowledge. Where are you? Whether you are in your Vs has the phase angle is the pi by 2 or twice pi by 2 where. So we have to synchronize our input voltage to generate this firing pulse. So So you can fire your thyristor here, maybe say 5/2 plus again 5/3, 5/6, that is 90 plus 30, 120 degree you can fire here. So you have to have the knowledge, where are you? So firing pulse need the knowledge of your input voltage. Let us see in your book how they have they suggested to generate this gate pulse. So this is the block diagram. Can you see it? Can you
Yes,
see
sir.
this?
Yes, sir.
Okay, so look here. First of all, what we have to do that this I can set the question from here, from your final. The syllabus I have decided for the quiz will be your diode with LS, diode rectifier, bridge, full bridge rectifier, diode rectifier with LS and without LS, and also the basic circuits of the thyroid. I'll post it, inshallah. I'll post it in your group.
Yes, sir. For today, can you just give a quick review actually
What quick review?
on the quiz?
Fine. Okay, let me finish. This one first. Okay, so this is the input voltage we have taken from our supply, and of course, this is your AC sinusoidal, and you can use a transformer here to separate the power side from the your the control side, and then this is the sinusoidal voltage you will get like this. You look at this is your desynchronization, they call it. So this is your sinusoidal voltage. Your sinusoidal voltage. Okay, so now what you will do, if you have this type of sinusoidal voltage, so do you know how to generate the sawtooth wave with this sinusoidal? By using op-amp. Sawtooth wave. So LM301 is one type of op-amp, and there is 741. 741 is another op-amp. You can use this op-amp to generate this sawtooth wave. Or there is a chips IC is available also that can be used as the sawtooth wave generator. Okay. So in the IC you have to just apply this desynchronization to a particular pin, and there will be a ground. You have to connect this ground over there, and there will be DC supply of your op-amp. What is the maximum DC supply of op-amp?
Yes, sir. What is that?
Maximum DC supply you need to operate any op-amp.
Sir, the rated biasing voltage.
Rated biasing voltage, that I am asking, what is the maximum one? Maximum voltage for the op-amp analog circuit?
Sir, for LM785, sir, it is 15 volts, sir.
Yes, for the LM or for the op-amp for the what is that analog circuit, it is 15 volt. You are correct. So you can use that one, and then of course the highest voltage you will get for the sawtooth wave, the peak value will be here. They mentioned that peak value like this, so that will be your 15 volt. Anyway, so you can generate this one. I am not going. If you want, you can go to the YouTube and you can see how to generate the sawtooth wave. Okay. So when there will be a pulse, positive half cycle 0 to pi, there will be a sawtooth wave like this. And if there is a negative, and there will be a sawtooth wave like this. And for the positive, there will be a sawtooth. And what is the maximum? I told you what is the maximum voltage you will get from the op-amp circuit. What will be the maximum voltage you can get from the op-amp circuit?
15 volt.
15 volt. Okay. Now you have a control. If you have the sawtooth output from here, then you must have a control voltage. That control voltage could be a DC or anything depending upon the application. So here they are using the DC. So this DC voltage is the control voltage. So you will compare. So do you know the comparator circuit? Have we studied the comparator circuit?
Yes, sir.
Also, so the chips are also available. If you compare this one, when your sawtooth wave process your this control voltage, so there will be single shoot generator. There will be a single shoot generator like this. And for the negative half cycle, they have avoided it. But of course, you can always generate another pulse here. When it is crossing, there will be a pulse here. When it is crossing, there will be a pulse here. So now, by changing the value of the V control voltage, so maximum value will be your peak value. Suppose you just increase the control voltage to the peak value. So while will you get the, suppose this is your 0 and this is your pi. So you're moving this control voltage to the peak value. Then where will you get this pulse? Omega with respect to omega t, where will you get? You are increasing the control voltage to the peak value of your sawtooth voltage. Then exactly what omega t you will get this firing pulse. At omega t equal to pi. Here you will get that pulse. If you are in the middle, you will get pi by 2. If you start just if you move this control voltage to the 0 voltage level, then your firing pulse will be at the omega t will be 0. You understand it? Hello. Alpha can be varied between 0 to pi. How? Are you listening to me?
Yes, sir.
So alpha can be varied from your 0 to pi. How? Just you vary the level of the control voltage. If the control voltage is 0, V control is 0. Look here, then it will be like this. So it is the comparator circuit will compare your this control voltage with the sawtooth wave, and the pulse will be generated omega t equal to alpha equal to 0. When if you increase the control voltage, and suppose you are putting in the middle of that sawtooth wave, then what will be your value of alpha?
Sir, pi by 2.
Pi by 2, right? And when suppose you have gone almost at the peak value of your sawtooth wave, then what will be your value of alpha?
Pi.
It will be pi. So this way, if you can move, if you use a say simple potentiometer, and then if you vary the this control voltage, then you will have the alpha, variable alpha between 0 to pi. You got my point or not? Hello. Just
Yes.
sleeping, sir. Sleep. No problem. You can sleep. You are sleeping, right?
No, sir.
No, sir. We're listening.
No, you are not sleeping. Good. Let me make it a little bigger. Okay. So you can read it, and then they are mentioning that what will be the alpha. This is the equation where will be the, if suppose your V hat sawtooth, suppose it is 15, and if V control is say 7.5, then alpha will be a 90 degree. You got my point or not? Look at this equation. Suppose V control is say 1/4 of VST. So VST will cancel, then your 180 by 4, and that will be your 45 degree. You got my point or not? So you change, this is constant, you change this V control volt, then your alpha will be varied. Okay. So now, this will be today we shall start this one. This will be your practical control rectifier or thyristor converter. So this part is the source voltage. So what is this LS? What is this LS?
So source inductance.
This is the source inductance, right? This source inductance we have inserted or it has come inherently.
Sorry, inherent.
Right. We did not do it. It is the source. Your source voltage has this inductance. And this one is the T1, like your diode. This is your T2. This will be your T3, and this will be your T4. And this LD actually, this is that has come from the load. That could have been a very weak value, could have a very weak value, or it has very low value. This is the single phase bridge rectifier, control rectifier with the thyristors. And this is for the three-phase rectifier. Three-phase rectifier we have not started yet. So there will be 3 legs, and that will be also for the diode. We shall discuss it, inshallah, in the next class. Maybe in the last class or maybe the extra class. Okay. Now I'm going to discuss these things using my whiteboard so that you understand very clearly. Okay, now I am sharing the whiteboard. Can you see the whiteboard? Hello.
Yes, sir.
You have 6.3. Single phase. So 6.3.1 idealized circuit. Okay, for the resistive load first, let us discuss for the resistive load. Now, I am trying to figure, look at how I draw it. So are you familiar with this drawing? That will be in your quiz. This will be T1, this will be T2, and this will be T3, and this will be T4. So did I draw correctly the symbol of the thyristors?
No, sir, they're diodes.
Okay, so we must put the gate. So we have considering the idealized circuit with LS equal to 0. So here LS equal to 0. So here your Vs. So Vs equal to Vm sine of omega t, and that will be your root 2 Vs sine of omega t. Okay, someone told me to discuss about the contents of the quiz. We can always discuss before the quiz. Okay. Let us see whether we will get any vacation or not. Sorry, not vacation, like any break, academic break or not. If you get the academic break, then you will have the quiz after the break. If you don't get the academic break, then maybe you will take the quiz very quickly. And before the quiz date, we shall take a discussion class, inshallah, extra class. And I will answer all the questions from you who are interested. That will not be compulsory. Those who will be interested, they can only join. Okay. Is it clear to you?
Yes, sir.
Yes, sir.
Good. So this is your resistive load. Okay, so the current is here say ID and the voltage across it say VD. And I'm asking again, I know that if I ask this simple question in the Viva, what is the VM here with respect to RMS value? So 25% student will not be answer. Tell me what is VM here by looking at the equation.
So √2 VS.
Yes. So you are all always answer. So what is VS?
Sir, VS is the
RMS value.
RMS value, sir.
I mean, in our country for the single phase, like at your home, what is the value of your VS?
So 220 to 240.
220 to 230.
Yeah, around 230 or something like that. Okay. Yes, you must know all these things. So this is your source connect, and this is the ID with your load connect. I want to sit in any class with you when the teachers they take the class by using this. What is this? What is the device I am using? Wacom. So how the lecture is coming to the students, I can understand how this one is going to be. Is it clearly going to you?
Yes, sir. Sir, rule আমি স্যার আমাদের এভাবে ক্লাস নাও।
Okay. Because we are the disciples of a same boss. So he was Dr. Waliuddin, and he was also head of the department of EEE in IUT once upon a time, maybe around 90 or something like that. So I one day I'll be just gossiping with you to relieve you from your mental anxiety, how I have started my journey. And now I am at the age of the finishing. I should inform all these things to the youngsters. I know that you are not interested to know the past, but if you don't know the past, then you cannot proceed. So now I have plotted this one. What is this? I have plotted this sinusoidal. What is
This
this?
is sinusoidal wave, sir. Actually.
Yes,
Sometimes
but
you
what
ask so
what is
simple
the-
question that you get confused. What is
what is what is this?
So supply voltage.
Supply voltage. Okay, thank you. Yes, I am asking you so simple thing, and you thought, oh, what will be the answer? I always ask you the basic thing. Okay, don't worry. So I'm very. So you make me smile, and that makes me feel better.
Thank you.
Okay, good. Okay, now we will have a pair of, you know, that this T1 and T2 will be conducting for the positive half cycle, right? And then this T3 and T4, this T3 and T4 will be conducting the negative half cycle. From the diode rectifier, we know that. Okay, for the T1 and T2, we'll have to apply the firing pulse. So I write down this way, IZ1 and IZ2. Same time we have to apply that. At the same instant, actually, we have to apply the firing pulse. And for the negative cycle, of course, this is your pi, and if it is alpha, it is also alpha. So this is your, this point should be, if you want to symmetrically, yeah, if you want to symmetrically apply the get pulse, you have to go pi plus alpha for the negative half cycle. Okay, so this is your pi plus alpha. We have applied that. This will be your IZ3 and IZ4. Okay, now we are trying to plot the ID and then IS, of course, and of course we look at the output voltage. So now tell me, 0 to pi, which thyristor should be conducting?
So T1 and T2.
T and T2. Why? Because they are forward biased. Okay. If okay, let me use the eraser. I am just forgetting this T3 and T4 rather than I am now plotting this one only. So look at the circuit. So yeah. Okay. Now the current, just follow my pen, please. The current will flow, IS will go this way, and if T1 is fired, if T1 is fired or T2 is fired, then current should go back like just like same as your diode, right? So now my question to you, from 0 to pi, 0 to alpha, from 0 to alpha, what will be the switching condition of T1 and T2?
Sir, it will be off.
They will be off, right?
Yes, sir.
So if they are off, then there will be no current. Then what will be our output voltage?
Zero.
Zero, right? Right, zero. Then at omega t equal to alpha, we have applied the pulse here at omega t equal to alpha equal to say 30 degree, for example. Alpha equal to say 30 degree, we have applied. So here, and then your T1 and T2 will just work as a diode, right? We have given the video. Can you remember the video? We told that this is your anode, this is your cathode,
Yes,
this is
sir.
your PN, PN. Then when we have applied the gate pulse here, then this P has become the N, so it is like a PN diode. Right or wrong?
Yes, sir.
So it will be just work as a ideal diode. Then it is short circuited, and then our the current will flow this way, this way, and this way, this way, this way, and go, and then your VD will be equal to your VS. That means here. And since this is the resistive load, so your current will have the wave shape like this, same as your voltage, and it will be zero. And at omega t equal to pi, then what will be the condition of your T1 and T2? At omega t equal to pi plus, what will be the pi plus? What will be the condition of your T1 and T2?
It will be off, turned off, reverse bias and
Ah.
turned off.
Right, it is because we got the zero current and also it's reverse bias. And then pi plus alpha, we the T3 and T4. Now I am going to again draw the T3 and T4. This is your T4 and this is your T3. So forget about your T1 and T2 now. Let me do this. Now the voltage has changed its direction. It will like this, and you follow my pen, please. Which color? Blue. The current will go this way, this way, this way, this way. IS current, look here, IS current will go this way. That is the T3. This way, T3. Then it in the load, it will have the same direction. And but it has come. And so IS will have the same. Now, okay, let us plot this one. Omega T and this is your IS. So IS will be same as ID, you know that, because it is the series circuit. This is your IS for the positive half cycle. Negative half cycle, is it going this way or in the opposite way? For the positive half cycle. IS. First, okay, first tell me. Before applying the gate pass to your T3 and T4, what will be the bias? What will be the switching condition of the T3 and T4?
They will go off.
Off, they will off. And also T1 and T2 off. So there will be no current, no voltage. So we will not get any voltage here, right? And then when we have applied a pulse to T3 and T4, then they are on. And then just like the diode rectified, we will get the output voltage same as your positive half cycle, and the ID current will have the same direction and you will get this thing. But now IS will change the direction. Am I correct or not? In the positive half cycle, IS will have the direction, and the negative half cycle, IS will have the opposite direction. And probably you have already forgot. So that will be the wave shape of the IS. In the negative half cycle, IS will be the mirror replica of whatever you have got in your load current. You understand it or not?
Yes, sir.
What is the time? How many minutes you have left? Times are left.
15 minutes. Oh, no, half an hour.
Half an hour, almost half an hour. Good.
Sorry, it's 23 minutes exactly.
23 minutes. I will take half an hour. Yeah, but there are some people who will go to mosques. Maybe. Hey, what is the time of your prayer time? IIT people. Okay. So now let me delete.
IUT period time starts as 1:15.
150. So I have to finish it by 1:05. Okay, so the wave shape output voltage will be like this. This is alpha to pi, and then this is your pi plus alpha. Well, this will be your EEE, or sometimes people call it again DUT. It does not matter. Okay. Now, if I want to get the DC voltage, what will be the? How we can get the DC voltage? Average voltage. How many students are here? Participant 80, 79. So out of 79 students, at least one should say how we can get the average voltage.
So average voltage will calculate the RMS.
Sir. Yes, sir.
That is not the average value. What is the procedure to get the average?
So we will integrate from
Alpha
alpha to pi, sir. Alpha থেকে pi পর্যন্ত
পার্টিশন করে ইন্টিগ্রেট করতে হবে স্যার।
স্যার তারপর
we
1
have
by
to
t দিয়ে
get-
টাইম পিরিয়ড দিয়ে ভাগ দিব।
Yes, this will be we have to find out the area. So area is, if you know the equation of this line, then you integrate it between your alpha to pi, and we know the equation of this, right? This will be nothing but your Vs. So √2 Vs sine of omega t d of omega t, and then integration will be your alpha to pi, and then you have to divide it by twice pi or pi.
So pi.
Pi, because it is repeating after half cycle, right? So if you do that, then you will get that √2 Vs by pi. Then it will be √2 Vs by pi cosine of alpha. You can do that.
Yes, sir.
Okay. Okay. If we apply alpha equal to 0, that means we are applying the get pulse here, and also at omega t equal to pi. What will be the wave shape of the output voltage?
Exactly as the source voltage. Oh,
Yes,
sorry.
exactly as
Full wave rectified circuit, sir.
diode rectifier, right?
Yes, sir.
And okay, so by varying the alpha, that means the phase control. What is the range of varying? You can vary the alpha.
So from 0 to pi.
Yeah, 0 to 180.
0 to 180. Good. So by varying this alpha, then we can have the controlled voltage. Okay, you got my point or not?
Yes, sir.
Good. Hey, how about the other students? Shout.
Yes, sir, we got. If all of us respond, it will be a chaos.
Yes,
So,
sir. It would be a chaos, sir. So maybe that's why they are not
some
a
of us respond
Good,
and
good. I am praying to Allah subhanahu wa ta'ala. I want to see your face very quickly. You understand what I want
Yes,
to say?
sir.
because in the class, time is going so fast. You know that what I want to mean is that I am counting every night when it's on. So I thought so my one day, maybe okay, if Allah subhanahu give 10 years more. So 10 years means that 3,650 days. So one is now it is I am counting down. You understand what I say? So that is why I want to disseminate the knowledge what I have got to my students. But I am really very much worried. You know that a lot of people are dying every day, and particularly in my age, but astonishingly, the people are also dying at the age of your age actually. At the like I got the news today. So in village region, there are a lot of young people are also there. So now I am taking the load is now ID control capital. What type of load I have is now here? If the current output current is constant, what type of load it is?
Sorry, inductive load.
Inductive,
Highly inductive.
highly inductive.
So what is the practical example of the highly inductive load?
AC.
AC.
It is a very big DC motor where the resistance, armature resistance is almost zero, and there is a lot of inductance. And then you will see that output current will be the motor current, DC motor current will be like this. Not exactly constant, but it will have some ripple, but we can take a constant. Got my point?
Yes, sir.
Yes.
Why I am telling all these things? Because the interviewer will ask you this question surely, and most of the interviewer they are the old people, and they don't have your 3G, 4G, all these things knowledge. So they are very expert in the power system, power electronics, all these things. So they will ask the question from your basic. You understand? So you have to get prepared for this one, for your future. So but most of you want to go to abroad, I am very much sure, and leave this country. And also you want to live with your parents. That's not bad. You will forget everyone. Right?
No, sir.
No, sir. I will take my parents also if possible.
Oh, okay. You want to take your
And
parents.
you
but
will
you
leave behind your teachers, right? And the other relatives.
and also, you don't want to be in this country, right?
Let's see, sir. Hope for the best.
Okay, good. So that is your IC1 and IC2, and this is your IC3, IC4. Okay. So now, same thing we are doing as for your resistance, but here this is the. So what will be the if I want to plot the ID? So is it okay if I plot like this? We have done that thing for the diagram. Is it okay? Because it is constant.
Yes, sir. ID is constant.
Y equal to C.
Sir, I
Right?
have a question regarding this kind of converters actually.
Yes.
Sir, we're actually changing the output voltage RMS value, right?
Yes. No, DC.
DC equivalent. DC equivalent of,
DC.
yes, sir. The output voltage of DC equivalent of AC circuit. But
Yes.
if I
Yes.
need, if I attach a appliance at the output side, which is sensitive to a level of voltage, which is actually higher than RMS voltage, what will it happen? Or what will be happening if the input is reaching in the peak side? I mean, we're actually changing the output RMS voltage, right? By
No,
truncating up.
this DC voltage. Yeah, of course, RMS value, there will be RMS value because your, look here, anything has a RMS value. Suppose your output will have that wave shape like this.
Yes, sir.
So if you do that, you will get the RMS value too. But we are not talking about the RMS value, rather than we are talking about the DC load. This is your AC to DC converter, and mainly our load is DC. We want to see what is the DC, and we have already found that the DC voltage will have that expression of like this. So if you change the, if alpha equal to 0, you will get 0.9 Vs, just like your diode, and if alpha equal to say pi by 2, then what will be your
0.
it should be 0. Actually, this is not the correct expression I have given to you. 1 by pi, then alpha to pi, then root 2 Vs and sine of omega t, t of omega t. So 1 by pi, then root 2 Vs minus cosine of omega t. Then it will be pi alpha, then root 2 Vs by pi, then alpha to 1, and then this will be the expression. Am I correct or not?
Yes, sir.
Yes, sir.
So that is not correct. So that I have given you, that delete it from your memory and also from the video. This is now if you put alpha equal to say 90 degree, look here how what we will get.
So root 2 Vs by m.
2 years by pi, sir.
Yes, root 2 will be. So the question is from you that we are actually changing the DC voltage like DC motor or any DC load. If you want to change it, the speed of the motor or anything, the DC load, you can use this kind of rectifier. Actually, we use this kind of rectifier to again to a inverter. Then we change this DC voltage, the inverter voltage will be automatically changed. Then that inverter output is AC, and that AC can be used for your, say, AC motor control or AC load, light dimmer, even you can use that. What I want to mean is that suppose you are using an AC to DC, then also on that one you can meet again DC to AC. Then this AC will be controllable. If you change this one, that means this DC voltage, if it is a variable voltage, then of course your AC will be controllable. You understand what I say? Yes or no?
Yes, sir. Yes, sir.
Okay. Let us go here. So 0 to, let us start from alpha to pi square, alpha to pi. Alpha to pi, again the current will move like this, and it will come back like this, right? So your output, what is that? The current is always constant, and we have already seen it, that this constant current will flow, and your IS current, if I plot IS current will be like this, up to pi, it will be like this. The same thing as your ID, right? Because IS is nothing but also ID. It is a series circuit. You got my point or not? Okay, now from pi to alpha, pi plus alpha. So T3 and T4 are already forward burst, but we have not applied any pulse. So will they conduct?
No, sir.
Okay, then, but you have the constant current. Current
Yes,
is
sir.
not zero. Where the current will go?
So
Where
the current will. No.
Then what happened practically?
T1 and T2 will conduct for
Yeah, right. It will be conducting until the T3 and T4 will be fired. Do you understand?
But we are not applying
T1
gate voltage, right, sir? T1 and T2.
Now T1, T2 we have already applied here, and it is on. And it is supposed to be off at omega t equal to pi. But current is not zero. Look here, current is not zero. So it will be conducting up to pi plus alpha. It will be conducting. T1 and T2. And then when your T3 and T4 will be fired at pi plus alpha, then shifting of the current will be done from your T1 and T2 to T3 and T4. You got my point?
Yes.
Yes, sir.
Okay, but the current will be always in the same. Look here. So if so, then when T3 and T4 will be conducting, of course IS will have changed the direction, right? We have already seen that in our diode case. If you see that T3 and T4, and it will go back to this one. So then we'll have that negative current from this one will be twice pi plus alpha. This is your, again, you have applied a pulse twice pi plus alpha. So that will be the conducting time for your T3 and T4. So look here, T3 and T4 will be conducting between 2 pi plus alpha. That means this period. This is this period not equivalent to 0 to alpha? Twice pi to twice pi alpha, is it not equivalent to 0 to alpha?
Yes, sir.
Okay, so if T3 and T4 is conducting here, okay, let us see what will be the output voltage. So when T1 and T2 will be conducting, output voltage will be Vs, and it is still conducting, it will be Vs like this. Then when T3 and T4 will be conducting, then output voltage will be again Vs like this. You understand?
Yes, sir.
So we see that twice pi to twice pi plus alpha, the output voltage is this one. So of course here also we will get the output voltage this one. And for this period, who will conducting?
So T3 and T4.
T3 and T4. So here T3 and T4, and here T1 and T2, and again here T3 and T4. You understand it or not?
Yes, sir. We
Yes, sir.
understand, sir.
Okay, so now
Yes.
the commutation. Commutation means the shifting of the current from T1 and T1 to T3 and T4 will be done where at alpha, at pi plus alpha, where the you are
Hello?
applying the firing power.
হ্যাঁ
Right, mute and then talk. All of your friends are listening to you. Okay, so you understand it or not? Hello, my sons and daughters.
Yes, sir. We understand, sir.
Okay, good. Now let us, let us see the output. What will be the expression of the output?
Sir, I have a question, sir.
Yes.
Sir, suppose at the time of triggering the pulse,
Mhm.
suppose T1 and T2 are open, T1 and T2 are operating because their gate pulse is present, so they're like working as a short circuit.
Gate pulse is only required to turn on. You don't
Sir,
need to-
suppose we have turned this on, so that means they're shorted already, isn't it?
Yes.
Okay, so at the very moment when we have shifted the phase, like sir, at the pi plus alpha position, so we have given another pulse. So,
Where?
sir, at the pi plus alpha position, didn't you give another pulse?
Another pulse to whom?
Sir, T3 and T4.
Right, exactly, because they are
Sir, my
followed by-
question is, T1 and T2 are already shorted within this time, isn't it?
Yes,
Before pi plus alpha, T1 and T2 are shorted, and
right.
at exactly at pi plus alpha point, T3
Yeah, you
and
are
T4 are also
yeah.
shorted. So, sir, at
Yeah.
the very moment, all the four are shorted. So, sir, how
You
they're
are
dealing with
correct.
this?
Yeah, you are correct. That is why there is a term they call it dead time. And practically, when you will implement this kind of circuit, so you must make a delay here. There must be a delay. We call it dead time. You must maintain a dead time, like as you mentioned that it is always conducting. So you have to make somehow a delay so that the circuit is not short circuited. You understand it or not?
Yes, sir. Yes, sir. That's why I was asking.
Okay. Now our output voltage will have that wave shape like this. And that is your alpha, and this is your pi, and this is your pi plus alpha. So the average value will be your T0, they may say that, or B0, whatever you want to say. You have to get the area of this one, right? So the area will be alpha to pi plus alpha, then root 2 here's sine of omega t, b of omega t, and divided by 1 by pi. And then if you do that, then this time you will get that cosine of alpha. You understand it? Now, if you put alpha equal to pi by 2, what should be your average value? This is your pi by 2, alpha equal to pi by 2, and this is your 3 pi by 2. What should be the average value? This area A1 is positive, this area A2 is negative, and the
Zero,
A1
sir,
equal to,
Zero, zero, sir, zero.
so that is why if you put alpha equal to pi by 2, you will get the 0 voltage. If your alpha is greater than pi by 2, then what should be your VT0? Average value, it will be positive or it will be negative. It will be negative. That is why it will work as an inverter. You understand, the voltage will be the negative, and but the current will be positive. So power will be negative. So it will be working just as an inverter. You understand it or not? So what is the time? I'm sorry. 12:57.
So that's 3 minutes. The quiz review to
Quiz review, I told you, you did not understand. So when the quiz date will be fixed, then I shall take one discussion class. You will have to fix a date, all A, B, C. Then we shall discuss or review all the syllabuses at that time. You understand it or not?
Okay, sir. Okay, sir.
Okay. Okay, now, okay, now let us go back. I don't want to say anything more today because time is almost over. And I don't want to make your life stop.